The EOQ and the EPQ formula are easy to mix up. Remember, it's most appropriate to use the EPQ formula when you are provided with a production rate. You can see that in this scenario. All restaurants within Adventure Center's parks grounds are supplied by a central kitchen. Okay, that's interesting. Fresh salad consumption is about 40,150 plates during Adventure Center's 365-day a year. Ooh, I just found something really important. The 40,150 plates of salad consumed a year, perfect. Capital D for annual demand, 40,150. I know I'm going to need that later. Anyway, it costs $8 to set up the salad workstation in the central kitchen, regardless of how many plates of salad are then prepared. I need to keep that also. What is it? 8? For $8? Because capital S is the fixed cost associated with an order. What you're looking for is an expense, and it doesn't matter how much or how little you make. That's exactly what they said. Okay, now there's some other information here. And each salad costs 80 cents. All right, I don't have a neat abbreviation for that, but I'm pretty sure I'm going to need that information. Maybe I'll store it up here. Unit cost 0.8, 80 cents. All right, well, what else? And let's see, once set up, the staff can, once set up, the staff can assemble 400 salads per day. Perfect. That is lowercase p for the daily production rate. They can produce 400 a day. If we had not known that we were going to be using the EPQ formula, like we didn't have this note frame and that's actually the formula that's pre-printed on the note frame, that sentence right there would have given away whether we were supposed to use that or the simpler earlier EOQ formula. Because the moment that we're told how fast something is made, it is more appropriate to use the economic production quantity, the EPQ formula. Oh, all right, now we're still not done mining this for information. The appropriate holding cost of a salad is 300% the cost of the salad. The annual hold, oh wait, I need to fill out this formula, capital H, which is always the cost of holding 1 unit in inventory for 1 year. They didn't say anything about that, but they said that each salad costs 80%, and they said that the cost of holding one in inventory for an entire year, that's what that means, is 300%, or 3 times that. I now have H. Because I say 0.8, the unit cost times 3 for 300%. Oh, it costs $240 to hold 1 plate of salad in inventory for a year. Now you're probably thinking, yuck, I mean, who's going to eat a salad after a year? Why would you ever do that? Good thought. We don't think that there is going to be any unit that is in inventory for the entire year, but we still have to remember that to get the formula to work, capital H is, even if it's highly theoretic, the cost of holding 1 unit in inventory for the entire year. All right, so we have an estimate, even though nobody would then eat it. We say it's $2.40. Okay, now, so we went through the information. We've got the parameters. It says what order size would minimize total annual cost. That is by definition asking for us to calculate the so-called EPQ, or economic production quantity. That's why it's been supplied here, right? So we're all ready to go to fill out that formula. And let's say order size. So what are we figuring out? We're figuring out every time Adventure Center Central Kitchen sets up to make salads, how many salads should they make? Another term for that in this kind of setting might be a batch size. But anyway, we just need to fill out the formula. So we say, okay. Well, let's see. So that means that it would be 2, right, times D. Oh, I've got D, 40,150 times S. Oh, that's right. I had snared S. That's 8. Divided by H. Oh, right. And H is that questionable $2.40, but that's what it is. Okay, we do that arithmetic, we take the square root, except wait a minute. That is then multiplied by the square root of p. Okay, that was 400 divided by p minus d, or 400 minus, whoops. Okay, now wait a minute. We almost got all the way through the formula based on the information that we'd mined out of the scenario. You're thinking, all right, well, D, I mean, that's the 40,150. Oh, no, wait a minute. Capital D is always annual demand. We remember that in these models, capital D is always annual demand. How many salads will be consumed over the course of a year? This right here is not annual demand. That D is for demand, but see how it's a baby d, a lowercase d? That means that it is daily demand. You say, all right, well, they didn't say anything about how many salads were demanded each day, but we could figure that out pretty readily because we know that 40,150 are demanded over the course of the year, and they did volunteer that they are open 365 days a year. And keeping with the assumption that demand is constant, because that is like one of the underlying assumptions of these formulas, that implies it's just logic that, oh, okay, they must sell, there must be about 110 plates of salad consumed each day. That's the number that we're looking for right here. Oh, all right, so I did that on my calculator. Comes out a little messy, but I get the 517.3651. It's what I get for this part of it, times, now wait a minute, this part of it. It is helpful to do the two halves separately, just to stay organized, equals about 607.6. You want to round to one decimal place? Oh, now wait a minute, there's no such thing as 607.6 plates of salad. So to actually answer Adventure Center, it would be logical to round that up to 608 plates of salad. That's the actual answer. So what we would recommend to Adventure Center is when you're setting up to make salad, make 608 plates of salad. Why? Because that's going to minimize these holding costs and these setup costs at the salad assembly workstation. Oh, now wait a minute, that's going to minimize those costs. What actually are those costs? There's a tag-on question here. What would that cost be? Now this that's provided in the note frame is the formula for calculating the total cost of any possible batch size. For instance, if you had just decided, oh no, they're going to make them 100 at a time, you would just put a 100 in for the Q in either place in that formula and then fill in all the other parameters, and it would tell you the cost of making them 100 at a time. What it's asking for here is what's the minimum total cost if we go ahead and act on that. We make it 608 at a time. I mean, how much money are you actually spending? We just fill out the formula. Okay, so the D is annual demand, 40,150, divided by Q. We have just appointed 608 to be our quantity. See, times S, well, that's that 8, right? Plus, okay, Q, 608, times P minus D. The P is 400, minus daily demand is 110, divided by, in the denominator, 2 times 400, 2P again, except wait, when you do that, right, that's actually your average inventory, by the way, you want to multiply it times 2.4. Why? Because remember, that is the per unit annual holding cost. So I did all that, and I got, like, over here, this half, 528.29 some odd, and over here, this half, I got 528.96 some odd, meaning that, well, yeah, you know, add them together, we're talking about their combined cost. The minimized total cost of salad assembly at Adventure Center's Central Kitchen would be $1,057 and about 25 cents. Oh, and you notice that they didn't come out exactly the same, but do you see how these two numbers here came out pretty similar when we were filling out the formula? Oh, right, because that total cost formula, if you're looking at it, this is the ordering costs, which also in our case we might call the setup costs. Same thing. This is the holding costs over here, and the EPQ, this order size, is finding the place where essentially the fixed setup costs and the holding costs are balancing. Now, its purpose, its stated purpose, is to find the lowest total combined cost, but oh, by the way, that's going to be where these two different costs basically balance. You can see how they didn't come out exactly the same. Oh, and that had to do with the fact that we needed to round to an integer, you know, from the 607.6 to the 607.6 to 608. Yes, but for any time you're working the EPQ, if you come up with an order size and then you put it back in the total cost formula, look for that. Okay, it could be off by a few decimal places, but should basically balance. It's a good check on your math, because if it doesn't, it does indicate that maybe you've made a mistake somewhere in the calculations.